Okay, here is Kurtz for an explanation about the trick to copy-paste a sample in the Renoise automation envelope editor. Of course, some of you tested the method, and of course it didn't work. I mean that if you try to copy-paste a sample like that directly in the envelope automation thing, it doesn't work. It doesn't work at all, because the sample file format internally has nothing in common with the clipboard file format of the envelope automation. So in fact, you have to understand first how graphical envelopes are converted internally to go into the clipboard, and then have a look on it, understand it, and then you will be able to understand the way to paste something in the clipboard and get a result in the envelope automation editor. So first, we're going to play our bass line, well known. Okay, this is a bass line I've rendered previously. Then I've converted it to 8-bit mono file, and then I've saved it and reloaded into Renoise. So you've got a 8-bit sample here first, and then we are going to have a look on the sample. Here it is. And then we are going to have a look on, for example, here in this track, I have added, for example, a simple DC offset thing, and I'm gonna change the DC offset here. When I move it, in fact, I move the signal, and then I go to the automation, and I can see the point here. So I'm going to, in fact, process and create random points. You can see those points here. Curve, for example. Let's copy it in the clipboard. Okay, it is copied first, and then I'm going to open a file, paste it inside, rename the file into an XML file. This is the secret XML, and then open it. Okay, it's opened. So what can you see? You can see that those random points are in fact converted into floating point values here, ranging from 0.0 to 1. Okay, those values are just converted on the fly, so you cannot have something big. You just have, in fact, a proportional thing here. For example, 8-bit samples are made of values that range from 0 to 255. So you get simply to convert this 8-bit data into a floating point data value. This is where all the trick is. So you get a lot of solutions for it. Maybe an LUA script would do the job, maybe a Visual Basic program or Delphi program. It's up to you. You choose whatever you want to reproduce here the XML structure and build your own converter. I'm going to show you mine. Simple, you see. For example, here it is. Here is my little converter. I will open my bus line. You can play it here. It's here. I open it and the conversion will start internally. Okay, it's simple. And then you've got the timer, and then you've got all the points here. So I copy them to clipboard, and then I just have to put my song in the beginning. I just have to zoom in and simply here I paste the whole thing. I use this button here. If I don't use it, it won't work. Okay, so you see that the envelope has been totally, completely copied here. See, there is a little glitch here because something isn't properly coherent. It doesn't look like the right envelope at the first points because these are WAV files. I didn't really cleanse them before, so you get to cut the selected time. These are a few points that don't represent sound, in fact, so you cut them at first. And this cut time will take you a few seconds depending of your computer. If you get a fast computer, you can just prepare a coffee, but if you've got a slow computer, you can add the bread, the butter, and read your newspaper. And after that you've read your newspaper, okay, you got your sample here. As you can see, when you zoom, you see the details. It's like in the sample editor. When you zoom, you see the detail. The same thing here. See, same thing. And when you play it, you will play it the same way. See, 8-bit here, 8-bit here. Okay, so the converter works. You can see it. And after that, always a question of sample playback. As you can see here, I've defined 220 for the BPM and 12 for the lines per bit. If I don't define something like that, frankly, it won't work. So I'm going to make a test. So in this track here, I'm talking about the DC offset track. I'm going to mute the sample track. In this track, you get a DC offset controlled by your automation curve here. It's controlled by it. Before it, you can see a line input device. The goal of this line input device is simply to feed the DC offset. So you can even put it to 0 with the volume, or it's just because you just want to feed the current, in fact, here, and this will work. I've just put a gainer here, and I've emulated a kind of a side chain compressor because I want you to hear my voice when the DC offset will work. So okay, we start the playback. I'm sure you hear it. Let's go into the automation envelope. It's like a nifty oscilloscope here. Works. And the original sample here. Of course, this is not exactly the same quality, of course, because in fact the definition anyway of the automation envelope are not exactly the same as the definition of a sample player, but whatever you do, even if you put it to curve, linear, or points, the same thing. Same thing. After that, you just have to compress it. You just have to add one or two effects because the sound is very low-fi in itself. So this trick could only be used in low-fi productions, or I don't see that kind of sound in a high quality track, maybe as a kind of an effect. I don't see you using this trick in an achieved mix because it's really dirty lo-fi, but it works, as you can see. Okay, it was Kurtz for a little tutorial about the secrets of automation envelopes and the way to copy paste something in it.